fine. Hello everybody. Okay, let's take a look what is happening here. Can't wait, let me also test Streamlabs and everything works fine with the streams. The stream seems to be healthy. Okay, let's see also if this chat is working. Test this one. Okay. Let's test the chat. Chat. Test. Yeah, it's a bit laggy, but it works. Test 2. Yeah, okay, everything seems to work fine. Okay. Before starting, I would like to start with my notes. Lab. Okay, let's put the microphone close to me. Signing. Signing. Okay. Stream notes. Yes, that's what I want. And okay. Okay. So right. Let's close that. Close that. And let's go back to issues. New issue. Actually, let's do it here so you guys can see it as well. Paste. And the title of the stream is Restarting Project. Okay. No. So almost 3 months. Huh. Yeah, it's February, March, April, May, almost 3 months. Stroke peak place at, let's say, 11:30 at 1:30 in, what is that? 9 of May of 2022. Yeah, I think 22 is fine. Stream starts at so how can I do the same? Oh, so okay, so what time are we now? We are at 11 minutes. Okay, so 11 minutes. Right. Why restart the project? Okay. So create this. So basically this, for those that are new to the stream, watch the stream later on. This is basically me Hopefully this stream is not gonna screw up. For time being, it seems that the stream is going well. I don't see any huge lags, and everything seems to work fine in terms of chat, etc., etc. So, hello everybody. Long time no see. Have been 3 months since the last time to. Oh, wait a second. It has a C. Roll on. What is that? Anyway, I was seeing something in my Twitch that does. So, hello everybody. Welcome back to the Ephestos stream. We are back with the project. I took like a few months hiatus, but I'm back, and I'm gonna be doing things a bit differently. Last time, I was trying to do things a bit of the hard way in order to make them the easy way. So what I was trying to do previously, for those that don't really know the project because it has been quite some time, I'm trying to make a sci-fi project which is based on building. It's a bit like Space Engineers meet Minecraft meet Elite Dangerous, you know, EVE Online, etc. This kind of stuff. So it's a sci-fi thing that will have voxel building mechanics. Nothing super fancy, but I was wanting to do this in Python. And I wanted to do this in Python because I really like Python. I think it's a great language, and I think it's much better than using JavaScript. We have started actually doing this. We started building an API for Python for Godot. I didn't want to use an existing Python approach that exists for JavaScript because it wasn't important for Godot 4, and I'm using Godot 4. And it was quite buggy, so I wanted to go with something that's a bit more stable and something that it is not going to be a full access of Python to Godot, which was the Tooliman was basically the one that was making that. So he can make like an API for Python for Godot that had full access to Godot. I didn't really care about that so much. I didn't mind using some JavaScript, but I wanted to do this in Python as much as possible. However, it's proven to be a lot of work. It's not necessarily super difficult to do, but it has been a lot of work for me to port Python to Godot, and I had to expose all the API of Godot, which is a huge API. Of course, Tooliman is doing this using automatic wrappers for Python. So I thought about this and I realized, you know, this is my first full game and I don't know what I'm doing most of the time. So I thought to myself, let's not, because the idea with Python was that I would try to test to see if that works for me, if it's really a good idea to do it. And I did this for a couple of weeks. It wasn't really, that took like, you know, the majority of my stream. It was basically an afterthought. So I thought to myself that I will try to make a branch on my code, see if the Python approach works, and if it feels that it doesn't work or it's buggy or it takes too much time, I will go back to using JavaScript. And that's exactly what I decided to do. I thought I'd sit down with myself, I thought about this, and I realized that if I do this in Python, even though Python will give me access to a lot of great new features, and you know it has a lot of libraries, AI, artificial intelligence, ID tools, and all this kind of stuff that I can use, which I'm not going to be able to use it from JavaScript. Well, I could use it from JavaScript if I use Python like externally, but probably I will not be able to do that. And I thought to myself, let's make things as simple as possible and make the projects as simple as possible, because I'm already trying to make it simple in terms of making it in low poly, in terms of making it, even though it's 3D, I try to keep it simple because I don't really know how well Godot is suitable for 3D games, because yes, we have the Godot 4 version that, you know, it has several releases, but we don't really know how well it's gonna work. We don't know what kind of bugs it's gonna have. It's pretty much an unknown. People already use it for 3D, but again, you know, we have no way to know exactly how well it's going to work. So I sit down with myself and say to myself, I'm gonna make the game as simple as possible, trying to avoid any technical complexity. I was thinking to use Python. I decided not to use Python now. I was thinking to make it fully procedure generated. And when I started as ideas, and that was basically ideas I throw in the wall, see how they work and what the difficulty is, because I'm also curious to find out how those things work, because I also like to learn, etc. But I decided also against that. I decided to just make in assets myself and probably, you know, purchase some assets if I have to. So overall, yeah, I decided to go back to making just a regular Godot game in 3D. Nothing special, nothing super fancy. Something that is going to be still interesting, it's going to be fun to play, and it's going to definitely be based on building things like a bit like Space Engineers. I don't think it's going to have physics, anything super fancy like that. But you should be able to make your own spaceships, your own star bases like you do. My inspiration basically is Empyrean Galactic Survival, but I don't really mention it as much because most people don't know the game. It's not that popular as much as No Man's Sky or Space Engineers or Elite Dangerous, etc. So I'm trying to make a project that is going to be for solo development, something not super difficult. Now, one of the things we were doing was doing things in Python, but before that I was trying to make starting using cube marching to make the procedural terrain generation, because the procedural terrain generation stuff is going to be in the game. There's no way around that, because this is going to be in a planet exploration game, again like Space Engineer, so it has to have those things, and it's not that difficult. We already have started implementing a cube marching. So what I want to see now is go back to the code, because I haven't seen it for several months, and see exactly what I was doing in that department and completely abandon the whole Python branch. Hopefully there's not much code difference. So okay, let's start it. Let's go and revise the code. Let's take a look and let's refresh our memory. So it's 18, refreshing my memory on the code. Okay, so let's take a look how things are right now. I'm gonna need to open a terminal, and I will have to go, I think it's in my home folder, coding, and inside here I think I have one that's called Cyclops. Okay, Cyclops is this one. Let's see this status first of all, that we haven't, okay, nothing is committed. So let's see branch. I think branch uses all the branches. Okay, so let's take a look at this. Check out Cyclops. Warning, unable to. Okay, so we have to remove those directories. Yeah, so let's remove those directories. GRM modules Cyclops CPython, because I'm not using CPython anymore. Okay, so let's take a look at modules then, because I used to use Python and I was building Python inside my project, so obviously this is gonna have to go. Let's take a look what kind of directory we have here. All right. Yes. Okay, let's open Visual Studio Code. Okay. I don't care about you. Let's close all these files, because we're not going to be working on those anymore. I want to take a look and see. So basically what I want to do now is build the latest version of Godot, which is going to be Godot 4, of course, and see what else we have here. Okay, so this is the project. So this is the project, and if I'm not mistaken, you have to go through, what is that? What is Ephestos here? What? What is that? I have the project inside. But it does still have those things. Why? Wait. Let's open it again. So let's go open folder. Let's go coding, Cyclops. Open that. So there's an Ephestos here. But there are Python files. Okay, the Python files are because... Okay, so I'm gonna remove those test files. They're not necessary. and I don't want them to be committed. And here we're gonna have a kick loops. Okay, so actually let's remove them right now. I don't think it's gonna be a problem. Delete this. Or delete PyTest. And go to modules, delete that as well. Okay, so let's delete that as well. Delete CPython. Delete cbuild. And delete virtual environment. Yeah. So okay, let's take a look at the terminal again. Where am I? Okay, it's status. Nothing. Alright, nice. So this means that those things are not committed in this branch, which is great. So this branch is clean. Okay, so what we're gonna do is go back to the master branch. Okay, let's take a look at what kind of branch we had. Where's the master branch? Master, okay. So check out master branch. Okay. Git status, we don't have a problem here. No. Okay, git pull then. And we have to pull a lot of things. Git pull. Okay, so let's take a look at remote v. So I get from Godot. Okay, so git pull Godot master. The camera is good. I think I need to lower it a bit. That should be fine. Yes. Okay. It's gonna be a big download. Right. So what I'm gonna do the next few weeks is gonna go back to cube marching, and now my plan for the game is anything that I do from now on is gonna be visual, 100%. Right? There's not gonna be no stuff like. I'm also considering of not making the game multiplayer because I think it's gonna make things more difficult. So again, I'm trying to simplify things as much as possible. And I said to myself, you know, if I want to make the multiplayer, I can always make it multiplayer after I release the first version. It's not. I don't think it's gonna be that much of a huge deal. So for now, I think I'm gonna go with a single player, which I think is gonna be a lot easier. So right now, my focus will be only on procedural generation of the terrain. There's nothing else going to be procedure generated. I used to think that I'm going to want procedure generated enemies and starships and bases. But I realized myself, let's again make things as simple as possible and go with the simplest approach, the easiest approach. And if things work very well and we see the project moving forward very fast, because the first 3 months obviously were very slow because I'm still learning to do game development. So I know the project's not going to be fast. It's going to be very, very slow. So we're going to go back to cube marching. And I'm not going to waste too much time trying to explain what cube marching is. For those who don't really know, cube marching is a way to take an existing 3D geometry that exists mathematically and make it into a mesh, make it into basically vertices, edges, and faces. And it's called cube marching because it takes like it's like a voxel thing, like a cube, right? It takes one cube at a time and trying to find inside that cube what kind of faces they're gonna go. And what it does is just it's trying to find if that cube is empty, which means that there's no faces inside, it discards it, and it only keeps cubes that are intersecting with the 3D geometry. So you have a cube like here, and the surface goes through the cube in some way. It can go like this, or like from the upside, of the downside, or left or right, etc. As long as there is some kind of geometry that goes inside the cube. Yeah, but if the cube is completely inside the geometry or completely outside, of course, it's considered an empty cube and is discarded. That doesn't generate any mesh geometry. So we have done already that. I've already taken code from online, and I was using cube marching, but I was trying to adjust it to Godot. So the way that I'm developing my project, for those that don't really know, is that I'm making like a game engine on top of Godot engine. So basically, my game engine is not an actual game engine from most people think about. It's basic stuff that need to be available for the game, which are developed as a Godot module. And those things will then be scripted through using GDScript. So the project is basically in C++, which makes the module side, which basically recompiles the whole game Godot engine and adds a module with extra functionality. And of course, the game itself, which is going to be mostly GDScript. So that's what's going to do now. Right now, we are updating to the latest version of Godot, and we will be rebuilding the project. It will take a bit of time though. Why it's so slow? It's only 30 kilobytes per second. Why? My connection is fine. Why it moves so fast, slow? I don't know. Okay, so let's refresh our memory what cube marching is, because I think this is gonna take a bit of time. Okay, so let's take a look at cube marching. So this is basically cube marching, right, to give you an idea. So you have those cubes, and they basically go through the entire geometry, and sometimes you have different layouts of faces that are intersected with the cubes, which is why it's called cube marching, because one cube at a time. This is an example of a 2D shape, basically, that uses cube. This is not cube marching; it's called square marching, because it uses squares, of course. And you can see that it creates an approximation of the geometry. So it doesn't. Those dots, those vertices it generates are not always on top of the exact geometry or the exact shape. They're like an approximation. So you get basically something like this. This is the kind of thing you have. Now, this is not great for sharp edges or precise geometry, but it's good enough for when it comes for terrain, because I'm going to be using for terrain, so I'm not going to be doing any kind of sharp kind of things. Like even if you take a look at the No Man's Sky, usually those terrains, because they are very low in resolution for performance reasons, they're not going to have. So another thing that I was thinking of doing is using also, the nice thing about this algorithm is that you can actually use it with compute shaders. So you can put it inside a shader in your GPU and accelerate quite greatly. But I will not do that either, because debugging shaders is basically a pain in the hat. And you can do, it has very cool performance when you do it from C++, because it's just the game is going to be low poly anyway. So I don't think there's going to be a huge need to move to the GPU, which I try to avoid because I know that's going to be a bit more difficult, much more difficult to develop in essence. And I'm already making it hard a bit difficult by deciding to do this in C++. But I decided that because I know from Empyrean it has a lot of performance issues. The problem with C# is that it's a lot slower than C++. I mean, it's a fast language, yes, but if you take a look at the benchmark, some benchmarks are actually 4, 5, 6 times slower. So it's much easier to work with, but it gaps performance. And because I will be relying mostly on GDScript anyway, for more of the less performance stuff, I thought that combined C++ with GDScript is going to be fine. But I'm also open to the idea of maybe using C# as well with Godot. Already the project is mostly coded in C++ anyway, so that's about it. Let's say, look how, where is it? 20%. Okay, so let's take a look at documentation again. I want to refresh my memory a bit of how cube marching works. Which one I was using code-wise? This is basically the ones I was using. Okay, let's make this larger so you can get guys reading. Yeah, so as I can say, it uses cubes that inside those cubes it creates faces depending on where they intersect with the geometry. So depending on how the cube is intersecting with geometry, it makes the regular faces. So this is how you can cube march a sphere basically. The sphere is described in terms of using math. So it's usually A, B, and C. I think it's, you have you can calculate the geometry of a sphere using mathematics, and then you use the cube marching to generate the mesh behind, because otherwise it's just a math thing. It doesn't really exist from a 3D point of view. In terms of a GPU, GPU of course understands only faces and triangles. So the idea here with cube marching is how we can take something that is purely math-based and turns into actually mesh geometry. And this is one way of doing it. Cube marching is another way. There's also dual contouring. Many new games favor dual contouring overall. Yeah. Is this the code? Yeah, this is the code I used. This is the code I used. And you can see here, I don't know if the web versions. This is the thing, this is the code I'm using. Yeah, this is the code I'm using. Okay. So yeah, we have, let's say that we have, this is the marching squares technique. So we have this kind of shape we're describing using math. This is mathematical only, right? So it's not exist as an actual shape in terms of pixels or in terms of faces, etc. So what you do is you lay grid on tip, which is basic squares. And then basically what you do, and that's how it works, you calculate the distance of the edges of those squares from the actual shape. So here you calculate the distance from here, you calculate the distance from here. And basically the red here means that you take into account which faces, which vertices and which corners of those squares are inside the shape. So you only take into account the ones that are inside. And then what you do is you calculate the distance or the weight of those points from the actual shape. And you take an average. You make an average out of that. This is why you can see that it doesn't fall exactly on that. You take an average of that and you make an approximation of the shape. And this is the approximation of the shape, which is why matching cubes is not a precise way to generate geometry. It only takes an approximation. And in 3D, you do the same thing. It's just in 3D, you just have an extra dimension. So now it's not matching squares, it's matching cubes. Instead of squares, you have cubes. And again, you take the corners of those cubes, you calculate the distance from the actual geometry, and you make an approximation. So you make an approximation vertex that does that. And what happens here, and what matching cubes have, which makes it very fast, is that it has already a table of existing predefined faces that are an approximation of every possible geometry. It has, I think, 255 possible combinations. And others, this is basically the only possible combination you can have, which approximate pretty much any geometry through the matching cubes. It's not very precise, of course, that is the sacrifice, but what you lose in precision, you gain in performance, and which is why I like it. And this is very great also when you want to make terrain, because terrain can be extremely consuming in terms of memory and processing power, because you have to generate all those things dynamically real time. So that, of course, takes a lot of performance. So you can see here that we have a lot of approximation. This is basically a foot, and it's not very precisely, generated. And you can see that we have also some artifacts here, which is unfortunately one of the problems of this approximation. And basically what it does here, it uses a smoothing algorithm to smooth out some of this. By taking every edge individually, creates like a smoothing effect that makes things a lot closer to the original surface. But you can see here we still have a problem here, a sharp corner, where we need basically a lot more, which is why you see the use of sparse trees, which basically what they are multiple resolution squares. So you can have more squares here because here the shape is more complex, for example. And that's usually it's called a sparse voxel tree. You use that for terrain because in terrain we have a level of detail. So we have, of course, less detail for distant terrain and much more detail for closer terrain, which you have for every mesh. Yeah. And I think there is an example where it actually shows smooth things out. And you have also some artifacts as well, some gaps you can have. Now you can see here it actually starts smoothing things out. So we have a much more, you see here with smoothing, you can see that's much more realistic, much closer to the original geometry. Because those geometries here are not using mathematics, they're using how's it called this? Laser data, which actually scans on existing objects, like in a human foot in this case. And this takes this kind of laser data, which I think is pixels, very high resolution pixels, and tries to, because it's slices, there are slices of the geometry, it then uses them matching cubes to generate the 3D geometry out of that. So there are definitely a lot of different ways to do this. There's other things that are matching as well. As I said, alternative is dual contouring, which is the problem with the dual contouring is that it's much more precise. This one doesn't give you sharp corners, unfortunately. You can see here that everything is very smooth and very blobby, etc. Where with dual contouring you can get sharp things, because in dual contouring it doesn't do approximation, it actually goes precisely inside the cube and puts only a single vertex. Which means that you need a lot more cubes to describe the surface, because you cannot have multiple vertices in a single cube. Which on the other hand means also it's not as performant, but also not as easy to parallelize. Dual contouring, it's a bit more difficult to parallelize when you want to do it as a shader, where March Cube is a bit more faster in this case. So, but again, you lose performance, you get precision. This is usually the case with anything that has to do with 3D, so it's no surprise there. So that's about it. Okay, so let's see, where we are now. 60 icebergs. Okay, that's great. Let's take a look at Godot. How has anything changed since then with the engine? Do we have anything new? News. Is there anything I need to worry about? So we had a dev shop, it's 3.5 beta, and we have an alpha in end of April. Okay. So let's see what new things we have. Okay. Animation libraries. Nice. Allow using self in lambdas. Okay, so take a look at some of the things here. Implementation animation to libraries. What is animation libraries? Why my internet so slow? Why you're so slow? I don't understand. Sometimes when I stream, things slow. Internet-wise. It's like someone... Okay. Instead of containing single animation contains libraries. Oh, nice. Libraries in continuations, the library name's empty, and actually does, you know... Okay, so let's try something different. Might sound okay. Let's go to Pro. Let's go to yeah, everything's slow, man. I don't understand why things are slow. Go engine. Oh no. Go.engine. Let's see. How many people are streaming colonies right now? Ah, okay, only 3 people. Ah, Oli is online. Okay. Fine. Alright, so let's go back to this. So this is libraries. Animation libraries means that they can have several animation in a single library, which is great. Oh shit, maybe that's the reason why the function. So let's see. No, things are more slow now. I don't know. Actually, let's take a look at my settings here. Settings, what kind of stream I have? Where's my... Bitrate is 2500. I may have to disable that. Make it slower. I think it has upped the bitrate, which is fine. So far the stream hasn't had any problems. It seems to go fine. We get in an average of 30 frames per second to 25, which is great. Yeah. Everything seems to be fine. Okay, so we have libraries here. Missing. Making possible to import scenes as animation libraries. Ah, you can import scenes directly. FBX, GLTF, nice. Making possible for animation tree to import animation libraries on its own, so it doesn't rely on animation player for everything. Okay. There's a menu now. Ah, okay. This opens the manager. So there's a manager now? Ah, you can do this from inside the editor. Okay, so manage animations. Explosion. Okay. Right, so this is animation libraries. It seems that everything's okay. So what do we have here? Import scenes as animation library, that's fine, that goes to the next previous one. Make tiny interpolate value static, remove argument name strings for release builds, it's fine. Fixing loading binary resources with float64. Make implement sync unique nodes. What is that? Sync unique nodes. Sync unique nodes. Implement go.engine. Nodes can be marked as unique to the scene in the editor. Unique to the scene in the editor. Which means unique nodes can be accessed by the prefix in any point in the path. From that point in the path, the unique node will be fetched. So basically, that means that the node only belongs to a specific scene. And how you do that? To make any node unique, this option has been added. Where's the unique node? Okay, so you have to enable that. What is the icon? Here it is. This node has to be accessed from anywhere within the scene. Okay, so it's basically like a unique name identifier, if I'm not mistaken. Okay. So you can have two things with the same name because they're unique, right? So that basically means that they are global. Is it? You can go from any scene and access that? That's one thing I want to know about. You know. So can I access from one scene a unique node from another scene? Probably I can. Probably I can. So this is only for nodes that want to fetch the other nodes from the same scene. So you need to use groups otherwise. What is this? What is the meaning of this? Maybe it's a syntax error, maybe he meant to say $sign. Probably, yeah. Okay, ladies and gentlemen, it means that we managed to pull the things of the thing. Is the thing of the thing here, so everything seems fine. There's a lot of stuff that can actually destroy our... Wait, I'm in master, right? Okay, so JIT branch. I think I'm in master, yeah. So, okay, let's go to Cyclops, check out Cyclops. And let's JIT merge master. So let's merge with master and cross your fingers that nothing breaks. Yes. Okay, so I don't think anything breaked. It seems that everything's fine, which is great. Let's do a JIT status to see that nothing has broken. Excellent. So now the big question is, what exactly I'm gonna do in the... Okay, let's take a look at the build scripts I have created here, because I think I have a build script here. First of all, close the outline. Okay, so what is that? No. Close that. Okay, so there's a build script here. Okay. Okay, so if I go... I'm in calculus, right? Okay, so if I do... build essays. Do I have to do build essays? Yeah. So this is for release debug, for debug, and display elements, execute Ephestos, and execute Ephestos 2D. What is that? 2D. Must be one of the... I used to make an Ephestos 2D version. I thought I would be making a 2D version. Of course, I abandoned this idea. So probably I have to remove this. Okay, so let's do an Ephestos release debug first. And see how those things are gonna work if it fails. Oh my god. So it should be... build... sh release. Let's see. Sorry. Okay, let's see how this is gonna work. So we are building Godot, and hopefully, yeah. What is that? No such file or directory. Bin Godot. What? What is that? Bin Godot. Okay, let's take a look at bin. Godot. What is that? Cyclops Python. No, remove that. Remove Cyclops. Remove debug. Okay, let's try again. Modules register. What it says? Cannot start bin Godot. What? Okay, so maybe I need to do a sconce. Things called sconce clear. So this is gonna remove everything and make a forced to make a clean build. Right. And now we can try again, because I think that's why I was failing basically. Oh, whoa. Is that an error? Yeah, there's an error. Okay, there's some kind of errors here. Okay, so let's take a look at this. We have errors. Okay, so let's start coding. Let's start coding. Okay, so let's go to this one. And this one is gonna be named Let's Start Coding. It's 58. Okay. So let's find the problem. It's in this one. Okay, let's open this. What is that? No, 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 no. I want this one. No, it's not this one either. Which one? Okay, so initial. Did you mean an initialized web P module? Cyclops module. Okay, so let's take a look at the problem again. The problem is here. It says an initialize Cyclops module. What? What is that? Okay, so right. Let's take a look at the inside Cyclops then. So Cyclops should be somewhere here. And it hasn't deleted those things. So, okay, so register types, Cyclops. Oh, why it's Cyclops and not? Okay, so I need to change the names. I don't like the names. Okay, rename everything. It should be Cyclops, and this one should be also renamed. No. So rename Cyclops. And right, so this one should be Cyclops. Cyclops should be the header file, and also this one should be Cyclops. Actually, let's make this the easy way. And control find. Yeah, so change that to Cyclops. No. Go here, Cyclops, and change that to Cyclops. So yes, correct. So that is gonna be the change there. That file is fine. Let's find also the header file. So here we're gonna do the same thing. Change that, and that. Okay. So register types is fine. Register types here is fine as well. The only question is there anything changed when it comes to making a module? That is a good question, because it seems that I cannot find the module for some reason. Let's try again to rebuild this. Do I get errors again? So it seems that I cannot initialize the Cyclops module for some reason. And initialize Cyclops module. So this must be the method I has to use. So let's go to register types. Is there an initialize? Okay, so where he finds the initialize function, first of all? There's a register and unregister function here. There is no initialize function. So that actually makes me suspicious. So where exactly finds those things? So this one doesn't exist. Where he finds this one? Okay, let's take a look. Find this one. Okay, so this one is where those things are defined. Okay, let's try this one. Okay, so let's go to the definition of this. So this one is defined in Cyclops module JSON registered sheet. Okay, so they have changed the API. They have changed the API, which means I have to go to documentation and see what exactly they changed. That's why it doesn't work. So let's take a look at the Godot documentation, Godot.modules. Let's see how now things are working differently in Godot 4. And I have to make sure that I'm using Godot 4. So it's not going to be stable, it's going to be the latest. and see how exactly modules working in God of War now. Because I know they try to merge how it's called? GT Native to Godot modules, and nowadays GT Native in God of War is basically similar to Godot modules. So let's take a look at modules. So how you find modules? Where exactly you do those things? I can look at the existing source code, but I want to, yeah, modules. Custom modules in C++, here we go. And blah, 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 blah. Blah, blah, blah. Blah, blah. Yeah, it's a register and register. But here it's initialize and initialize. So haven't they updated documentation? What exactly you have done? Did they have changed? Did they change the register and register? It's the same thing. Then why creates this error? So there's a register types, which basically is here. So let's compare those two. So this is the register type I have in my folder. And okay, let me close the other files so I'll make a comparison. Okay. So right now, this is my file. Wait. This is the header file. Why you open this? What is that? What is that? GT native? What is that? Oh, no. That's a main folder. Okay, so this is the difference. So this is a new way of doing initialization. So basically, okay, let's compare those. This is a CPP file. Okay, so my CPP file is register types, which is the same thing here. Class database, which is the same thing here, and the header file, which is the same here. But we see here that it has a difference. It has void initialize JSON module. So they have changed the names here. It used to be register, now it's initialize. A register class, which is exactly, no, actually it's different. All the API is different now. Okay, let's take a look at other things. Okay, how exactly it does it here? So yeah, they definitely have changed the API. It's not the same anymore, and for some reason I have it documented. Yeah, module level sync, so it's the same the way. And it's a register thing. Okay, so let's take a look at GLTF. Oh, this one is a big one, but it's okay, let's go with this one. So GT register class is basically by registering class. Okay, so I'm gonna change that to this one then. Why they haven't added the documentation though? That's what I find weird. Let's say documentation here has the old method. So it has the register and unregister, which used to be the 3.5. Now that's not good. They have forgotten to update the documentation here. Possibly, yeah. I think, yeah, they have forgot to update. I think they have forgot to update the documentation because the same documentation here. So this one should be different. This one is no longer the way it works. And actually, I have to ask myself, is anything else different here? Okay, so let's take a look. This one is actually nice because it's a very simple thing. Okay, so where's the register? The register classes. Should be somewhere here. Oh, what the hell? So wait a second. What is going on? This is errors. Yeah, how you register now the methods for GDScript? Yeah, but how you register that? You don't? It's all complete automatic now? Okay, let's say header file. That's weird. That's weird. Okay, so BMP doesn't have that. So what we can do here that we can access from GDScript. Okay, let's go with JSON. JSON CP, so does it register anything here? So the whole module system has changed. Shit, that's not good. So it seems that the whole module system has changed. There is no registration anymore. Oh, no, there is. Here it is. Bind method, so it does seem to be the same. No, it hasn't changed. No, it's actually the same. Only the initialization has changed for the module. Okay, let's do it and let's hope for the best. Okay, so what we need then? Let's go here, close that. So we need, okay, let's copy paste. No, I don't want this one. I want the one with, because this one doesn't register anything. I want this one. Okay, let's take this one. Copy that to my own register types and do it like that, which means void initialize Cyclops module. So let's name them Cyclops and Cyclops and again Cyclops module. It troubles me that it has errors though, so I'm gonna go here and comment this out. I'm gonna keep it just in case and see. Okay, it does an error out now, but it does error for module initialization. Why? Because it needs okay, yeah, I need to change the header file as well. So let's change the header file as well, which is gonna be okay, let's copy that. Copy. The problem is, okay, let's keep. Okay. And the other one is yeah. Let's do it like that. Okay, let's go here and change that. Everything's so much more difficult because it has to be much more difficult. And this one. Okay. So we comment this out as well because it's the odd way of doing modules. Okay. So why has a problem here? Module installation undefined. So, okay, so let's go with this one. Register types. Okay, so here has a include, let's say it doesn't include register types H. Okay, core object class DDB. Core object, right? Let's move it together. Core object class DDB H, closure H, and the name of the module. The one thing I don't understand is this the class is all capitalized. Ah, it's capitalized completely. Okay, so that's fine. So that may work, maybe not work. Okay, let's try it again. Let's release that. No, it still fails and says that... What? Initialize Cyclops module. So it still complains about... Ah, okay, here, void. Expecting initializer before void. Oh yeah, it's not a void? It's void. What? What? Void initialize. Void initialize. Void initialize. Module initialization level. Yes. Why works for this one? You can find here. Wait, this one is inside. Yeah. What the hell's going on? Void initialization RPC module. Void initialize. Yeah, there's nothing wrong. What am I doing wrong? What I'm doing wrong? Uh-huh. Module initialize level sync. Okay, so let's see what we got. Okay. Cyclops, that's fine. Yeah. So it has here, initialize Cyclops module was not declared in the scope. It wasn't declared in the scope. Okay, so let's say the first error is here. Expect initializer before void. Expect an initializer before void. What? Void initialize. Initialize. Cyclops module. Okay, let's take a look at the header file. Void initialize module. Ah, we haven't done that. I think this one is not. Where's my header file? No. Where's my header file here for Cyclops? No. Give me the header file. Okay, give me the header file. Yeah, I haven't imported the module here. So we have to do, first of all, oh, I haven't done that either. I haven't done the guard either. How the hell have I forgot the guard? Okay, so let's do that. Control copy. And that. And I think you have to do an end if here. And if. And this one should be Cyclops. And this one should be Cyclops as well. Okay. Let's see now. Where's the... Ah, I forgot the semicolon here. That's why he was complaining. Okay. Seems to build, which is nice. It's nice when he builds. Let's take a look at the stream as well. How is the connection? Perfect. It hasn't been unstable for quite some time now. Okay. So yeah, everything seems to build fine. I don't think we're gonna have any errors, which is great. Which is definitely great. Whoa, 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 whoa. Oh, there's errors. What is errors? Okay, so vector doesn't name a type. Did you mean vector 3? What? Oh shit, they changed that too? So we have to fix those code, yeah. So everything seems to work fine. Okay, let me do another rebuild. To see the errors more clearly. You should do this now faster. Okay, so it says here it has an error. Okay, so I'm gonna start working on the errors now. Now I'm gonna actually start working on the actual code and see what is missing and what we need to fix in order for this to work for us. Right, so let me, before doing that, let me go here and say 120. Start fixing the errors. Okay. So, yeah. So let's start fixing the errors. Let's go here. So the error is in which module? In this one. Okay, so according to this, there is no, which line? There is no vector. There is no vector anymore? Really? What the hell they did again? Okay, so let's take a look at this. There's no vector. Really? There is vector. What? What? Okay, so let's take a look at this. Vector 3. Nope, there definitely is. This type exists. So what the hell is going on? So vector 3 is part of the vector module, most likely. No, it's not. Where's the header file? What? Keyboard action. Okay, let's find it again. So let's go here. Let's call this one. Let's find the definition. This one is defined in, yeah, vector H. So what the hell creates an error here? Vector doesn't name a type. What? What? What's going on here? That definitely is a type. Vector 3. Maybe that's a problem? Vector 3. Maybe I should also import the vector there. Let me. What was that? Vector H. Which is vector H core templates vector. So let's go here. Okay, let's try include core templates vector H. What about now? Does now that work? Okay, we have an error. So no such file. Okay, where is that? In wait, what? Keyclub CP. What? That's wrong. Let me change that. Rename that to Keyclubs. And first of all, it's actually Keyclubs. Oh shit! Tell me that I haven't. Oh my god. Okay, so control find. You have to change that to... Oh. Okay. No other results. So it was only this one that was wrong. Okay. So this one should go with Cyclops here. Right. Make sure so the Cyclops header file is correct. No, it's not correct. Let's change that to Cyclops. And I think it's fine. Okay, let's try that again. Okay, we have a new error. But still, we haven't fixed it. So that one should be, yeah. Okay. So let's try again. Okay. So we don't get any errors now, which is good. Means that we are going to be let's change the music. I want something more quiet, more melodic. Yeah, I haven't built it before, so it's gonna be a bit of time to take to actually build everything. I think overall my code is correct. I don't expect to be any kind of problem. Let's go over the code again. Haven't really checked this code for some kind of time now. It seems not to have any problems. First of all, the one thing I want to see is what kind of things we register for. Odd, reset, get. Well, we have the voxelize method here. The voxelize method is doing the ISO approximate, which basically is the one that triggers the cube marching. But it doesn't return anything, does it? It takes the grid size, the voxel size, and it doesn't return any data we can examine from GZScript. So we have to change that because I would like to use GZScript to inspect my C++ code. And currently, we only call the C++ code. We don't really expose any data for it. So for this to work, we have to do an initialization of this object, which is a Cyclops, because this is going to be registered from the GZScript side. The added value and reset and get total is nothing more than the example of the God's module we can find in the documentation. So these methods will be removed. It's basically those methods here. Count, add, reset, and get total. So I'm gonna remove those because I had those just for making the this is the only method that actually does the whole voxelization process. So we had in the grid size and the voxel size. Voxel size basically defines how big the cubes are gonna be when it comes to cube marching. When the grid size, it basically defines how many voxels we will be using for the voxelization process. And then it exposes this function from GZScript, so we can call this voxelize with passing these two arguments from GZScript. But we need to find a way to return also a list of data so I can examine from GDScript. Otherwise, this is only, it's not going to do anything. It's just going to generate some data in memory that we don't have access to from GDScript. I don't know. How are we going to expose that though? Well, we have the grid size and voxel size here. What is the sum h reference? This is the base mesh. So this is basically what we want. The sphere function is basically, because in this example, all we do is voxelize a sphere. So we use a simple sphere function, which is, I think, is, in which file is it disqualified? I think it's in the CI, so surface, if I'm not mistaken. Is it here? What is sphere defined? The sphere is defined. No. Maybe here? No, this is only declared. Where this one is defined though? Wait, if it's defined here, that means it defines in the header file. In the simplify, so wait, what? Here it is. So this is a typical function, mathematical function for describing the surface of a sphere. So you take the x and y position in the square. So you square the x, you square the y, and you square the z. And that here, the minus 10 is basically the radius of the sphere. So here I've taken a sphere of radius 10. And I create it mathematically. So you may say, okay, how this actually, how this defines the geometry? Well, this basically returns a value and basically tells you how far from the surface. If you take a point outside the sphere, or even inside the sphere, it takes you how far the point is from the surface itself. And that's called what we call distance functions. And we basically use what's called science distance fields. This is very common when you do geometry, when you do, procedural geometry, procedural terrain generation, procedural mesh generation. You use usually science distance fields. Science distance fields also are used for other things, like in Godot is used for lighting, and in Unity and Unreal are used for ambient occlusion. So the nice thing about science distance fields is that they can be used for a wide variety of effects. You can use them for normal maps as well. They can describe normals and pseudo geometry using normal maps. And in this case, basically what it does is we take a point. Let's say that we have a sphere here and we have a point somewhere here, and we want to measure the distance. And the reason why we want to measure the distance is because we know exactly where the vertex or the edge or the face is going to be by measuring the distance from that. And in order to do that, you'd use this equation basically: square x plus square y plus square z minus the radius of the sphere will always give you the position from a sphere. Of course, you take the position of what? The position of the point you take as a sample. So the sphere is always assumed to be on 0, 0 coordinates. So you don't need to worry about the position of the sphere because you know it's going to be 0, 0, 0. You only need to worry about the sample point you take to find exactly from the 0 point, because of course you know how far it's your point from the 0 coordinates, right? But you don't know how far your point is from the surface. And this is exactly what this calculation gear gives you. This is basically the radius. So did we fail? No, we succeeded. Okay, so let's see if he opens. It's not here. Okay, so wait a second. So we have built the project. There is a bin and there is a Cyclops. Okay, so let's take a look. Why I cannot open Cyclops? I haven't moved the Cyclops SH there. Okay, so let's take a look at CD bin. Oh, that is not CD bin, sorry. CD out, CD out, CD bin. And this should be a Cyclops, Cyclops. And now we'll see if it opens Godot Engine. Right. So it seems that it opens the Godot Engine here. Where's Ephestos? Coding Cyclops Ephestos doesn't exist. Okay, so remove that. Let's import the project from import it from Where am I now? Kilon, yes. Coding, where's coding? Coding. Cyclops. So here should be an Ephestos. Oh, what's the project? I don't have the project here. That's not a problem though. Okay, I'm gonna make the project. No, it's no problem. So I'm gonna make a new project. No. Make a new project. And it's gonna be, of course, inside coding. Cyclops Ephestos. And yes, and the project is gonna be called Ephestos. Yeah, that's fine. Create and edit. Ooh, it's not non-empty. No, it has to be empty. Where I can delete. Why he keeps making? Wait. No, remove that. No, remove that. Actually, let's delete everything and the import. There's an import here. Wait, what? Yeah, let's delete all those things. Wait. This is the Ephestos? Wait, no, that's main. No. So it's empty now, right? Okay, well, where's my create project? Create and edit? It's not okay, let's use the folder because that's to annoy me. Okay, so let's go to coding, Cyclops, Ephestos. No, there's nothing inside there. Why it says non-empty? Well, whatever. Open it. Okay, so it seems that it tries to open Godot. So the build worked. Right, so the folder is empty right now. We have created a new project. And now we're gonna need to make a 3D scene. And inside there we have to add, let's say this one is, this is the root node, so let's rename that to world. This is our world. And make a script here. Attach a script. How you attach a script? Attach a script, which of course is gonna be JavaScript for this world. And I wanted to make something that will initialize my object. So it's gonna be Kai. Var Kai. I think it's wait. Yeah, so var Kai equals, I think. I forgot completely how. I think it's called new, right? Okay, so this is what this. Let's call this one just for testing. Testing, yes. So we'll create this one for testing, and let's execute this and see if everything works. Yeah, select current. So it seems that there are no errors here, which is great. And let's go here and call voxelize sky. Yeah, so this is the voxelize. We need the size of the grid is gonna be, let's say, 20.0. And then we need the voxel size is gonna be 1.0. And save that and see if that works. So it shouldn't create any errors, and it shouldn't crash the engine. So it doesn't create any errors, doesn't crash the engine, which means that the code works, which is great. So now we have to find a way to expose the data of the voxelization to JavaScript. So we can examine the data from JavaScript if we have to. I mean, I don't have to examine from JavaScript. I can use also the C++ debugger to examine the data if I want to. But it will be nice to control everything with JavaScript and don't have to do anything super fancy. Right, so, okay. So, let's go back to the code. Right, so one of the problems we have here is how I call the build. So currently I use a Cyclops SH, which I don't think I'm going to use anymore. Do I need to use this from a command line? No, I think that generally speaking, well, I don't know, we have to export the project otherwise. Yeah. Well, it's not a problem. I'm gonna be able to call it from inside the command line anyway, so it shouldn't be a... okay. One thing I want to see is... what? No, don't do that. One thing I want to see is the build SH. Do I have anything here that allows me to open the project like that? So in order to open the project like that, from the command line, because I like to do everything from the command line. Okay, so you go to build SH. Okay, so this is the bin. So we have here one file. Let's take a look at the build SH, which is this one. So I can actually open. Yeah, you have execute Ephestos. So what does execute Ephestos does exactly? So execute Ephestos does this, bin Cyclops. Okay, I use the mega. Okay, so I'm not going to be using mega anymore. We instead going to be doing this. We're going to be using the local folder, which going to be it's not bin. It's let me think. It's Ephestos something. Project. I think it's that, right? Let's take a look. It's Cyclops. Actually, no. Yeah, it's Cyclops, which is the main directory here. Ephestos. Yeah. And it's a project. Okay, so let's try this. This should work. So if I go here and do execute Ephestos, it says that I cannot find your bin. No, it's not bin. Wait, what? No, there is a bin. Where's the problem? Bin Cyclops, not such file or directory. Okay, let's take a look at this. So we have the bin here, Cyclops. What? Why? I'm CD bin. No, it shouldn't be CD bin. There's no need for the CD bin, I think. I don't know why I have CD bin there. Probably it has a different setup. Okay, so that works. Okay, so that's great. So now we can actually open the project very fast without any nonsense. And it works. Okay, let's look at the errors here. Vulkan 0.2, but only supports loader interface 4, interface Blazor, blah blah blah. So it says about supporting Vulkan. Yeah. Okay, we have here an error in object of type. Well, where's that? That's not mine. That's part of the engine. It seems that it creates an error here. It has the correct version and type of my GPU. And it has 2 complaints here also for GLTF. So there are some warnings here and one error for Godot. But the good news is that that's not the errors. That's not errors for us. So the one thing I'm going to do here is I'm going to remove this because this one is no longer needed as a parameter. And I'm going to go up here and remove this entry here because I'm not going to be making a 2D version of Ephestos. There is no need for that. Okay, so let's take a look also. We can build the debug version, which we also need in case we have crashes. So this one also shouldn't take much because when we build the release version, it also builds very fast than the debug version. So for those that don't really know, when we work in C++, you can have 2 different versions of building things. The first one is the release version, which is basically the normal stuff you execute when you are a user. And then the debug version. The debug version tends to be a lot larger because it contains what you call the symbol table. And the symbol table tells to the debugger, when you use the C++ debugger, where which part of the machine code, which part of the executable corresponds to which part of the source code. So this is very important because if you don't really know that, you don't know which part of the source code crashes, or you cannot navigate through the source code using the debugger. So it basically creates this kind of map that tells the debugger where to find the appropriate executable code for that piece of source code. And unfortunately, this makes the executable a lot larger. So you can end up something with several gigabytes instead of hundreds of megabytes. And it also makes the executable a lot slower. But of course, the debug build is not for the users. We don't really give the debug build to the user. We always give the release build. The debug build is for us as developers that allows us to have more extra information and allows us to capture bugs a lot easier, and especially crashes, which is difficult to catch. So we need a debug build and we need usually a release build when we code in C++. So I'm going to make a debug build as well here. And then I will have to go to the source code and see what I need to do to expose my data to GDScript and how we're going to expose this data. This is going to be very important because inspecting the data to GDScript will allow us to know exactly what we're doing and that we don't make any mistakes and that the code we generate and the geometry we generate is really the right one. And of course, the next step is to display the geometry, right? So we have to create generator, and then we basically what we're going to do is we're going to assign that geometry to how we call it, a surface tool. The surface tool is basically one thing you have from inside the Godot engine. You can also access to on GDScript. The surface tool is a way for you to create dynamic geometry that Godot offers you. And you can do that by taking an array that describes the vertices and the index. So this is array basically has 4 items inside. It has the index array, which is basically which vertex connects to vertex, which basically creates the faces. It has the vertex array, which describes the position of the vertices. And it has a normal array that generates the normals for, I think it's vertex. And it has the tangents array, which is for tangents. I think tangents are used mostly for tangent maps, color, vortex color, something like that. So usually tangents are not necessary. To give you an idea, normal, if you think of the normal as being, let's say this is a surface, so the normal is always going to perpendicular to the surface. A tangent is always parallel to the surface. So generally you don't need to know the tangents because if you know the normal, you know that the tangent is going to be always perpendicular to the normal. So generally you don't really need to know the tangents. Although maybe you didn't know that because you need to know the direction of the surface. So you need to know if the direction of the surface is this way or the direction of the surface is this way. So for that I'm not really sure 100%. But I know that Godot doesn't really force you to use tangents. If you don't provide the array of the index, the vertices, and the normals, Godot is going to complain and tell you I cannot really create the mesh. Although you can't generally have a mesh without a normal because well, can you? Not really. No, you can't. You still need normals. So normals can happen in 2 ways. You can have normals based on the surface. So you have the normal being always perpendicular to the surface. This creates what we call flat shading. So it creates basically this kind of, if you ever see flat shading in Blender, where everything becomes blocky and you can actually see the faces because there's a sharpness between the edges. But if you want to achieve a smooth result, then you use what we call vertex normals, where vertex normals there are different for every face. So the same vertex will have a different normal for one face and a different normal for another face, even though they share this normal one another. And that is important because it allows you to interpolate the normals and create this kind of smoothing effect, what we call smooth shading. So that's about it. Now this algorithm I'm using is using smooth shading. The Wagix. Hello, Wagix. You are restarting the project? Yeah, actually, I'm not technically restarting the project. I used to work on a branch because I used to have several branches here, and what? JIT branches? What? Branches. So it's branch. So I used to have several branches. I can see here I have one that's called steps. I have one that's called Python, and one's called Python runtime. This one basically was for loading Python as a DLL. So I will allow to load Python during the execution of Godot. So after I open Godot. Well, this one was my standard one I used to work, which was loading Python at the same time the Godot engine really starts executing. And my idea was to use Python because I felt that it's a much more powerful language and there are a lot of libraries I can use that can help me out, speed up the process. But in the process I discovered that it's going to take a long time to expose Godot internals to Python. And it's a much more difficult than technically because I have to read the source code of Godot, I have to be 100% aware what Godot is doing. Because if you don't really deeply understand what Godot is doing internally, Python can actually crash Godot very easily. And this is why Tuliman, which is the guy that had the Godot Python module, which is for Godot 3, the last time I checked. I don't think he ported yet in Godot 4. He also experienced a lot of crashes. My implementation was supposed to be a lot more limited, so I wasn't trying to do what he does, which is basically fully expose Godot into Python. I just wanted to, use Python for some of the things. But unfortunately, Unfortunately, it's a lot of work. No, that's the conclusion. Feel free to call me Yag, by the way. Hello, Yag. Yeah, unfortunately, it's a lot of work to do that with Python, and I decided to simplify everything and go back to the initial plan. So before I started working on Python, I was working on procedural terrain generation. And yeah, and we go back to that basically. Procedural terrain generation means that I want to create basically terrain, like he does here. There is also another solution to that, is that there is a module that's called go.voxeltools, which is made by Zilan. So this is another thing I'm considering using if terrain generation becomes a bit too difficult. So I'm thinking giving like a month to get into terrain generation. Basically what I'm trying to achieve is this thing here. So this is made by a guy that's called Zilan. He's a great coder. I'm basically aiming for something somewhere between this and this. Probably not that much texture. So I'll go for something more low poly. And he has this project which allows you to basically use voxels that I do. He doesn't use cube marching. I think he uses dual contouring, which is a much more precise technique. It's a bit slower, but it's also much more precise for sharp edges and all this kind of stuff. So he can make much more realistic terrain in essence. So you can see here he can make real-time 3D terrain editable in-game. So you can editing is also important to me because I want to implement mining inside the game. So you allow you to mine the terrain like you do in No Man's Sky. So he already has that. He has things like overhangs and tunnels, which I would like to also have, like cave systems. And he has also physics, which is not something I care so much about currently, but it also is not a bad idea to have. So he has things like physics and collisions. He has also fixed the one problem here, that is terrain by paging chunks, which means that you load the terrain piece by piece. And that also works out for you to level of detail. So you have terrain that is low resolution in the distance and high resolution when it comes up close. So basically his tools are pretty powerful. So I also consider using his tools there, right? So it would make things a lot easier. The problem, however, was that he didn't support God of War. But he says here that it does. I don't think his code works for God of War. I think I heard somewhere that he was working on a God of War implementation, because I work on God of War, and the reason why I work on God of War is obviously much better render engine and much more features, which basically are ported in 3.5, and because God of War is the future, right? So this project is gonna take years, so there's little reason for me to not work on God of War. Yeah, so I'm also considering using his code. I think his code also is something I can base my code on, which is, I think he's using an MIT license. I think it's the MIT license he's using here. Yes, this is the MIT license. So as you can see here, has also nice documentation, which I really like. And it has quite an extensive API. And I think, if I'm not mistaken, he makes a GDScript. So basically you control all that from inside GDScript. So you control all that from inside GDScript. I may actually do an effort to find whether I can, because one of the things I can do is use his voxel tools and contribute to his repository. If I see that is the only caveat here is, oh wait, there is God of War support. There is a God of War support. So if there is a God of War support, I'm seriously thinking of using his build, his module, and build my module on top of his module in essence. Okay, that's interesting. Okay, so what we're gonna do in the next stream, because I'm near basically ending the stream anyway. What we're gonna do in the next stream, I will probably work on building his his module and see how well it works in practice. I think that's what I'm going to do before I start working with array marching cubes, because basically what I want to do is super basic. I want just to have basic terrain generation, basic cave system. So I think most likely his code is going to fit my needs for the project. And I can always become a contributor to his project as well if I want to improve things. I'm sure he's going to welcome anyone that can help him. And I'm already in his, I think I'm already into his Discord, because he also has a Discord. Yeah, I think he already has a Discord. So there's a God of War. Says that GitHub Actions. What is the GitHub Actions? This build responds to master version depicted in the changelog. A new build is made each time commits are pushed to the main branch. But also when developers make the pull request, in case there are multiple downloaded artifacts, the editor will be the one with the op tools in the name, because it is built with optimization enabled and includes tools. Okay, so this seems to fail though. This one succeeds, this fails, so I see a lot of failures here. Right, so we have to test this. We have to see how well it works in... oh, we have a raid. Hello, Oli boy. And I was getting ready to raid you. I was getting ready to end the stream and raid you, actually. That's funny. Hello, welcome. Raid from down under, okay. Get ready, guys. We invaded from below. Welcome. How was your stream? How everything's going? Yeah, it seems that it fails, but we'll see. I will have to do this in the next stream. I'm not 100% certain. Okay, so I'm in his. Yeah, this is what it is. This is basically his. Got it. So basically, this is his Discord server. I probably will jump in, and you can actually discuss with him, and he can help you out, understand what the project works for. So actually, yeah, I may use his code. I don't think there's really necessity for me to making a factory game in code. So like Factorio, right? Something like Factorio. I have one game that's factory based, which is, which one was it? Which one is the one that I actually liked? It's called Dyson. I think with Dyson spheres, right? Is it Dyson? Dyson something? Yeah, Dyson Sphere Program. This is actually pretty good. I do like this one. Dyson Sphere Program, which is this one. Steam. Probably you know about it. Dyson Sphere Program. Although I've probably going to need to bust out some C++ at some point for my logistic system performance, I think, but I'm a bit too noob at this stage. Yeah, so... Yeah, C++ is a pain in the butt. I will not recommend anyone to actually go down the C++ route unless you know what you're doing and unless you really need the performance. Frankly, even with my project, I will probably go focus as much as I can on GDScript, because I think GDScript is going to be good enough for the project. I think the combination of C# with GDScript is also very good. If you need better performance, going with C# is a better option. But yeah, C++ is fine, but it is a pain. There's a lot of problems and things can go wrong. But C++ can be 5, 6, 7 times faster than C#. So when you need the performance, you can go C++. But then, of course, you can also avoid going C++ if you do everything on the GPU. So if you do things on the GPU, let's say you use compute shaders or you use just a shader, because nowadays with God of War we can use shaders to also do mathematical computations. You can actually still stick with GDScript and use a shader to do the acceleration, because the shader will work even 100 times faster than C++ in some cases. It depends on the parallelization you're doing. If you can massively parallelize your problem and having the same loop running 1,000 times or hundreds of times, then of course you can benefit from using shaders instead of using C++. So it really depends what you're trying to do, of course. But yes, shaders and C++ is generally a good idea to avoid them because they're usually difficult to debug and difficult to fix bugs. Yeah. So this is the game I really like, the Dyson Sphere, which is very nice. Dyson Sphere program, yeah, exactly. Yeah, Factorio probably more like Satisfactory, Shape0. I don't know Shape0, I don't know Satisfactory. Dyson Sphere, great game, five developers only. I think it is Chinese, right? I think it's Chinese developers. I'm trying to design as parallel as possible in terms of my data abstraction. So you want to make a logistics system. What do you mean by logistics system? Is it like pathfinding thing? Logistics system, are you... Yeah, so for moving things around, or you have like a database thing, you mean? Are you talking in terms of a database? If you work on terms of a database, then I will recommend you could use a database API instead. So you don't have to code everything from scratch. So yeah, if you want to do database stuff, I would definitely recommend using something like SQLite maybe, which is high performance, and it's pretty light as well, and you can embed it inside the game. SQLite is actually is very popular with Python. We have it's basically the standard database for Python, but also used a lot by developers. So if you want to deal with a lot of data, if you have you have to deal with data and you have tables and all this kind of stuff, SQLite is a great library to use. Very small, very light, easy to learn, easy to understand. Massive amount of documentation, massive amount of tutorials online. And yeah, and I'm not going to be surprised if someone already ported this to GDScript. GDScript, let's say, SQLite GDScript. Maybe someone had made, yeah, here we go. So there's already a native wrapper for it. I don't know, it's 2 days ago, which means it's recent. It's for Godot 3, of course. And yeah, and the nice thing about SQLite is that basically SQLite is for databases. So I mean more about moving stuff around a factory. Yeah, but what you do exactly when you move stuff around a factory, that's the big question there. Do you want to keep the data and... yeah, so if you want to move data and you say, okay, in this factory belongs this kind of stuff, and have these items, and produces these items, and then you want to move that stuff and say, okay, now those items go to that factory, and that other, blah, 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 then yeah, using something like a database makes sense. People, game developers usually use things called entity component systems. But for me also, databases also are extremely important because they're highly reliable and they can be very well. This one is actually very highly performance library. I think it has multi-threaded by itself, by default. The nice thing about SQLite, and this is why I call SQLite, is it puts everything in a single file. So you don't need to have the usual database structure, which you have to have a server, which is another executable running on the background. And you have a client that connects to the server, and there's this kind of connection, right? But I think you can use it as a client-server kind of thing. So SQLite basically is meant more as databases, like a music list, like you have your music, or you have database that's local to the computer you are using. So for a game, I think it's a good option. And again, you're gonna find a lot of documentation, and from the looks of it, also here there is a GDScript implementation. You can build with Godot. And the nice thing about SQLite, it works on any platform. So it's completely closed platform. It works on iOS, Android. It works on, I think it works also on web pages as well, if I'm not mistaken. So it's very, very flexible. And yeah, and it's very light. It's also very light, it's very high performance, very small in size, because usually databases can end up being hundreds of megabytes. So this one is actually very small. So I think it's a few kilobytes in size, if I'm not mistaken. The actual executable, the actual libraries, I think there are only a few hundred kilobytes, maybe a few megabytes. So even this is actually, the SQLite can run on even embedded devices, I think, if I'm not mistaken. They actually use even on embedded devices. So yeah, this is a very flexible, if you are familiar with SQL, it's a very flexible way to work with the devices in a very light way. So I definitely recommend it, because I may use something like this for myself as well, I have to say, because I will also have a way to track things, because I'm making a building game. I'm not making a factory game where you have a lot of moving parts, but I will make in a building game that you have to manage your item inventory, you have to manage multiple star bases, because those star bases will have manufacturing inside, like building your own weapons. This is standard stuff you do in Empyrean. So I'm gonna be moving down a route similar to yours, although your implementation probably will be a lot more complex than mine. You are all familiar with Oracle SQL. So if you are familiar with SQL, yeah, SQLite is definitely gonna make sense for you. Yeah, absolutely. So this is another thing. So what we're gonna do in the next stream, I will take now a 2-hour break. I will do some physical exercise and just go to eat my lunch. We're gonna go back to this and work with this baby here. And we're gonna work on how we can generate terrain. So there's actually a YouTube video as well for those guys that want to take a look how the voxel tools are working. Voxel tools, Godot. And if we go here, this was from 1 year ago. I'm gonna remove the audio because for copyright reasons. And I'm gonna show you guys how really flexible the system really is for terrain generation. So let's take a look at, there's a lot of blah blah. So usually I want just to show the demo. Right, so this is the way you can excavate terrain in a Minecraft kind of way. So it actually supports a Minecraft look, but also supports an organic terrain kind of look, a more realistic terrain. So this is how you can excavate. So this is useful if you want to do mining, etc. And then this is the realistic. Terrain. So you can see here you excavate again. So basically the difference between the first version and the other is that this one uses a smooth algorithm that allows you to smooth out the terrain in order not to appear very blocky. So we're gonna be building this in the next stream and testing it and see how fast it is. I do like the way it is. It seems pretty cool. And this is basically what I'm trying to achieve as well as a result. So I don't see why I should record this myself. It's gonna be too much extra work, which is not really necessary. And yeah. So you can see here the geometry is quite high resolution if you want it to. And it has all this beauty that has the infinite terrain kind of look, which is because I'm going to be exploring planets. When you have a planet, you have a planet exploration game like a No Man's Sky, which is basically what I'm aiming for. You need to have an infinite terrain, right? You have to terrain that basically is the size of it's not going to be the size of a planet. It's going to be probably 10 times smaller, but it's going to be, or 1,000 times smaller. It's going to be like a sphere with a radius of 20 kilometers. So I don't want to make a huge planet, so the player takes like forever to explore. Probably we'll go for something smaller, because if you make everything in a real scale, universe-wise, because I'm also going to have space exploration, it's going to have run into problems like floating point precision problems, which means because you get very large floats there, you get like hundreds of millions of kilometers. A float can gives you imprecise values, and that can end up in creating havoc when you calculate things. So you have to do all sorts of special math to make sure that your very long distances do not get all jumbled up, and you get effects like stuttering and all these kinds of things. So generally, many people, solo developers, try to use much smaller planets, because there, instead of working on 1,000 kilometers, you work only on a few kilometers, and makes the mathematics and the math a lot easier to manage, and you don't have as many problems as well. So yeah, you can see here it uses normal maps. You can use normal maps to save the terrain as well, which is great. Yeah, and we're gonna work on this on the next time and see how sophisticated it is. So let's find someone to raid. Finished for now. Let's see who is now in software development and game development. Am I the only one as usually? Software development. Okay, is there anyone doing Godot right now? Okay. There is one that's doing Godot, which is called Babe Des Boys. What is that? I don't know. Godot 2D as well, I see here. Let's take a look at which we're gonna rate. Okay. So this one is, let's remove the music. See you, Ollie boy, see you. Thanks for the raid, man. You're gonna burn to death, but enjoy any heaps for the games. Yeah, man. Have fun, enjoy, rest, have a nice sleep. Game dev, pixel art, Zion League. Oh, okay, let's go with this guy. That's fine. Okay, so his name is Bud the Boys. Is it English? No, it's French. Oh, no. Let's go with English. So, okay, so we only have this guy. So, Super Mac Dev. Okay, let's go Super Mac Dev. So, thanks everybody for joining. I will now raid. And thanks Ollie Boy for the raid. So, we're gonna be coming back in a few hours with taking a look at the voxel tools for Godot. Megadev. And yeah, and I'm gonna go back in a couple of hours working on a build for voxel tools. I want to test the voxel tools and see how well it is and how advanced. And yeah, thanks everybody for joining. And you will see you in a couple of hours and see how we're gonna go from there. Thanks everybody. See you later. Bye bye.